Hello guys. Today I want to talk about the basis of geometry, and what I mean by that is the basis of Euclidic geometry. Euclid was pretty much kind of not really the founder nor the inventor, but he wrote a book called Euclid's Elements, which is a book that he wrote, I think it was like 300 AD. This book was really the first book that brought all of the I don't know how to explain the concepts, would it be? The ideas of geometry into one book. He synthesized all that. That's why it's called the Euclidic geometry. If you look through this book, if you buy it, which I have, and you look through it, it's quite hard to decipher what he's saying. For example, just the language that he uses is difficult. For example, he said that a point is that with no part, which means just that a point is just that, it's a point. It has no part, it has no length. He said a line is that with no breadth, which means it has no defined length. It's just that it goes on forever. It is straight. It goes on forever. And he wrote these things, which are just common sense. Okay, these are his axioms. He wrote his propositions in there. Propositions that, like, for example, if you have a line segment and you want to cut it in half, the way to do that back in Euclid's time, because they had no rulers, all they had was a straight edge and a compass. So the way that they did it was with definitions. A circle is all the points from the center to its side are equidistant. So meaning that the radius, whichever way you shift it, whichever way you rotate it, it's always, the length is always r. Definition of a circle. So he used that definition to draw with a compass circles. And as you know, I'm not drawing this with a compass, so it's not going to be, as you see, perfect in any way. But the idea is simple. This length here is radius. This length here is radius. The compass, these circles were drawn with a compass. These radiuses are the same, making these lengths the same. Okay? And now here's where a little bit of the logic comes into play. If you have a line and you have a point, the shortest length from the point to the line will make 90-degree angle perpendicular to the line. And if you think about it, it makes sense. If you think about it, if you were to shift this this line, it would need to be longer for it to actually reach the line. So this is something that that had to be a an axiom. It had to be a postulate. So once with that accepted, if you don't accept it, think about it for a minute and just close your eyes and think of the circle, and think of a line and a point, and think of its length. The shortest length is when it's perpendicular. With that said, this from here to here will bisect it, and it's perpendicular. Yeah. So what I'm trying to get to is that all of these geometries, it's all based upon these axioms. A line is straight, it goes on forever. A circle is all the points a certain radius away. And pretty much with just these definitions and some logic, you can do all these different things. This is how the Greeks did it all. They, if you wanted I don't know, I think I'm running out of time, but this is how you do everything. If you want to bisect an angle, you take a circle, you draw your lines. This radius is the length of that radius, and then you draw again another circle with the centers of where they intersected there. These again being the same length, this radius and this radius being the same length. So then it bisects it. You see, it's all based on that principle. If you think about it, you just have to figure out a clever way to do what you want to get. Get what you want to do. One last thing. Degrees. Angles. I don't know, 45 degrees. This means this is just a measure that was invented after like the Pythagoreans and after time. The Greeks didn't really have a measure. This is just a concept, you know? They say a triangle has 180 degrees. Really, well, how can you prove that? There's actually a way to prove that. If you draw a 90-degree triangle, this is 90 degrees, and you draw a line parallel to this line, like that. Well, then this is 90 degrees.